Welcome everyone to our Senior Design Showcase. My name is Alex Ventura, and this is Levi Bushing. Today we'll be showing you HuskerScope 4.0, the fourth iteration of the HuskerScope project. HuskerScope as a whole tries to be an accessible way to access commonly used electrical kind of tools in order to test, view, and analyze electrical circuits.
So this semester we were working for the UNL School of Computing, and this device has in the past already been used in the Advanced Embedded Systems course. We wanted to expand the uses for it. And so the tool that we have provides a way for students to test and validate their designs that they make in class without the need to go to an electronics lab or purchase expensive equipment for the process. And because of this, HuskerScope is used by students all over the world in electrical and computer engineering.
Okay, so let's meet our stakeholders. First, we have our project manager, Bill Browning. He made sure that we always followed the process and was there to help with any issues with the agile process. We also have our tribe lead, product owner, and sponsor, Professor Falkinburg, the main vision behind the HuskerScope, and who was there to outline our requirements and make sure and provide help whenever we needed help with achieving them. As well, we had our coach, Christian Zuha, who was there to provide any help we needed along the way.
Our team was these 6 members here. The developers were myself, Bin Wu, McLean Beach, Trent Beekman, and then Kobe Christensen was our product manager, and Alex here was our squad lead and development manager. We were mostly computer engineers with the exception of myself, who's in electrical engineering. But being mostly computer engineers, I think this gave us the unique opportunity to work on a project that had not only a software component, but also a hardware component to it.
So to understand where the HuskerScope 4.0 did, we have to first understand what the previous 3 years did, right? So they implemented a web app that had a function generator, an oscilloscope, AM and FM modulation, a spectrum analyzer, and the initial starts of a logic analyzer. All of those were mostly focused in the audio range. So for HuskerScope 4.0, we wanted to extend that audio sampling capabilities outside of that audio range. So traditionally, audio is between 20 and 20 kilohertz. We wanted to be able to at least read 500 kilohertz signals. And we also wanted to finish and extend that logic analyzer page. So it has 8 channels to read 8 different signals at once. And to extend it, we want to implement triggers. So being able to start reading when the signal goes high or low. Timing, so to see like how long a signal takes and how long is it high and low. And additionally, decoding. So that would be simple decoding such as PWM. What's the percentage of it being high versus it being low? And in order to achieve these requirements, we had to first create new hardware. And additionally, we wanted this hardware to support BLE and serial so that we could connect to both PCs and mobile devices. We also wanted to have RAM storage so that way we could store more samples than just what we could on the device alone.
And to expand on the hardware component of it, throughout the course of the year we made 2 different designs, one in the fall and one in the spring. The previous team already had a board. Unfortunately, the filter on it wasn't very good, so the signals that it produced didn't have the same shape that the input signal did. And so just to walk through what we have on the board is at the bottom we have 2 analog pins to read analog signals. It then goes into our filtering circuit, which will take a -5 to 5 volt input and make it into an acceptable range for the FPGA. On the right side, right below the FPGA, we have some digital pins that will also feed into the FPGA. The blue board in the middle there is the FPGA that does most of the signal processing that we need for this board. And then it feeds it to our ESP, which is the black board on the top there. This board is mostly used to send the signals out, so we can either connect to it through a serial connection or through a Bluetooth connection. What we improved on for the spring semester was we also added a RAM chip kind of up in the right-hand corner. And so this was to give us more samples in the buffer, and so that we didn't need to rely on only using the BRAM on the FPGA.
Yeah, so once we had the hardware figured out, the first step was connecting that hardware to the software. That we implemented our own protocol and was able to connect to it. And once we were able to have that connection, we wanted to focus on improving the logic analyzer. So some of the things we did was we improved the rendering speed. We added the ability to rename the logic analyzer channels. We added digital cursors, so you can see, you can drag the cursors across and see how much time passes between them. We also had rising and falling trigger support, as well as digital timing. So you can kind of see here on the slides that 300 and 400 microseconds, as you hover over the different signals, you can see how long they are in time, as well as digital decoding at the bottom. So here we have some example PWM signals that have 75 and 50% signals just alternating back and forth. We also were able to improve the oscilloscope auto zoom, so that way it looks nice. When you give it a signal of any kind, you can click the auto zoom and it'll try to make it look nice on the screen. All right, this leads into our results. So throughout the course of Huskoscope 4.0, we were able to increase the sampling rate with the hardware, able to connect over serial and Bluetooth to both web and mobile, and we were also able to improve the logic analyzer, implementing the digital timing and as well as the digital decoding.
And throughout this process, the things that we've learned is foremost that clear communication throughout the project leads to more comfortable release meetings, especially just looking at what the sponsor wanted and how we could implement that. In a few release meetings, we would draw diagrams or look at other examples of existing hardware equipment to have a model of what we could do in our own design. Also, we found out that user experience is very important, and our sponsor did a good job of helping keep this in perspective, giving us stories about students from his class that have used this technology, and also kept us honest with the iOS approach to make sure that the mobile didn't fall behind the web app implementation. So thank you guys for coming to this project. If you do want to check it out more, you can search up Huskoscope in your browser. There's the web app there, or you can also download it on mobile. So if you just want to play around with it, we encourage you to take a look at it. Thank you guys.
Yeah. Any questions?